Multiplying monomials. We need to do a little vocab review as we get into working with polynomials. So polynomials is an expression with a combination of variables and coefficients. The variables have to have only whole number exponents. Each term of a polynomial is separated by a plus or a negative. So we're going to look at a classic polynomial. 3x squared plus 8x minus 7. This is a classic polynomial. And the different terms I want to point out, these three items are each separate terms in the polynomial. And there is a coefficient in front of the x squared term, that is the 3. And the single x term has a coefficient of 8. So we often refer to the terms by the variable part. So the x squared term is the first one, and we have the x term, and then this last term we call a constant because it has no variable part, so it's just -7. So that's a typical polynomial, but they can also get more complicated or strange looking. So here's another polynomial. And this is a completely valid polynomial. You notice there is a fraction for a coefficient, but that's totally okay. All the exponents of every variable are whole numbers. So even if they're really high, like 28, that's okay. And it doesn't matter if there's a bunch of variables throughout, like x, y, and w. It's still a polynomial as long as the rules I've described are applied. So we're going to start with monomials, which are the simplest polynomials. They're polynomials with only one single term. So for example, that would look like this, 4x squared. That's one single term polynomial. There's no other part added or subtracted to it. Another example would be -3xy. That's a monomial. And another one would be 101. So just a plain number is also a monomial. So there's no variable part to it, but it's still a perfectly valid, you have a coefficient essentially, or it's just the constant term. That's still a perfectly valid monomial. Now we're getting to the reason why we're looking at polynomials and monomials, which is that we can multiply them together using our understanding of the exponent rules. So let's multiply some monomials together. This first monomial, we've seen examples like it. We multiply the number parts, 3 and -4, we get -12. And then we multiply the exponent parts. Well, x squared times x cubed, we can do that with our product rule that we learned about. So -12 x to the 5. And now then we've multiplied our monomials together. Here's another example. What makes this one slightly more complicated is that I have a fraction of 2/5 times 15 for the number part. So I'll work on that in the next step. But then we can do our common bases. So when we're doing multiplying the variables of our monomials, we multiply the ones with common bases. So a to the 4 times a is a to the 5. And b to the 3 times b to the 3 is b to the 6. And now let me work on this fraction part. Well, 5 on the bottom cancels with 5 of the 15, leaving me with 3. So 2 times 3 is 6, a to the 5, b to the 6.